Hello and welcome everyone. Today we will be discussing the specimen paper for ISC 2025 for chemistry. This time the council has given the specimen paper along with the answers. However, the answers are not the model answers, they are more like hint. So we will discuss in details how to write the answers in exam so that you can score the full marks, especially those students who get 65 or 66 out of 70, but due to some silly mistakes they cannot score 70 out of 70. We will try to cover up all the points so that you can score maximum marks. So without any unnecessary talk, let us start because the video is going to be a lengthy one. Now, in section A, 14 marks, under question number 1, you will have three part A, B, C. A will be the fill in the blanks, B will be the MCQ, including assertion reason questions, and part C will be a paragraph based questions. So, in fill in the blanks, the common rule is you have to write the answer for both the blanks. According to council marking scheme, if you write the answer for one of the blank and leave the other, even if you are correct, you will not get the marks, because if you are writing for any one blank, then the examiner cannot understand whether you are writing that word for the first blank or for the second blank. So be it correct, be it wrong, you have to write the answer for both the blanks so that if one is correct and one is wrong, then for the correct one you get the half marks. So I am not going into the subjective details because that you are preparing. I am mainly focusing on the marking scheme, how to write the answer so that in spite of being correct you don't lose the marks. So you can write the answer in this way only. You don't need to copy the full sentence here. Only correct question number, that is question 1 part A part 1, for the first blank increases, comma, for the second blank decreases. Similarly, for the second question, for the first blank the coordination number is 6 here because ethylene diamine is a bidentate ligand. So two such ligand will give you four donor atoms here. Four bonds are formed by the two ethylene diamine ligand, one by chlorine chlorido ligand, another by nitrito ligand. So coordination number 6, and oxidation number you can calculate. This NO2 is -1, chlorine is -1, outside it is +1, so cobalt obviously +3. Now here one more point very important. Suppose you have calculated and you find that the oxidation number of cobalt is +3. You cannot write the answer here in number +3. Remember, in fill in the blanks type question, the word which is given, see the direction of the question, fill in the blanks by choosing the appropriate word. So you are choosing the appropriate word from the given list of words. So if it is written here in words THREE, you have to write THREE. You cannot write +3. In that case, you will lose the marks. So this is the basic for fill in the blanks question. You have to write the answer for both the blank, and you have to write exact the same word that is given in the bracket. You cannot write the same thing in another form. Now I am moving to the next one. MCQ type of questions. In MCQ type of questions, some of the students, we see it that you get stuck in two options. You can eliminate two options and you know that out of A or B will be the answer. So sometimes what you do, you write here A and the statement you are writing is corresponding to B. This will not work in your ISC exam. So in the answer for MCQ, if you write B part 1, if you write only D and you don't write the statement, you will get the full marks. If you write B part 1, you don't write the D but you write the correct statement, then also you will get the full marks. Anyone. But the best way to write the answer is You write the option number as well as the corresponding statement. This is the uh, most convenient way of representation for MCQ types of question. First question is related to the basic character of amines, and in basic character of amines the most important question is the basicity order of methylamine and ethylamine in aqueous phase. You can refer to your textbook. In aqueous phase there are two factors, hydrogen bonding as well as the inductive effect. So for methylamines it becomes 2 degree amine greater than 1 degree amine greater than 3 degree, and for ethyl it becomes 2 degree greater than 3 degree greater than 1 degree. So this question is coming from that part, which is very important for your IC exam. Next, colligative properties of a solution. So four statements are given. Read the question carefully. For this type of question, many times we see that after reading PQRS, they directly write the answer P or Q. No, PQRS are the four statements, and then your options are ABCD. So always you get plenty of times. 3 hours is more than enough. So read the question properly and see what they are asking. Now, in question number 3, it is related to the Markovnikov's rule. So, see, if you don't read this question properly, you will miss this word not. And that is why, if you see the uh, original paper given by the council, the specimen paper, you will see this word not is written in capital and it is in bold form to make you understand that read the question properly. If you don't read it properly word by word, you may miss this word not and you may write some other option as the answer. So Markovnikov rule is not observed. That means it must be an symmetrical alkene. So it will be butene. So the answer is B, butene. Similarly, see number 4, acid is not asymmetric. This not is very important. So all the 20 alpha amino acids which are necessary, including both essential and non-essential, only glycine is there which is optically inactive. There is no chiral center. So this is a very important short question, very important information regarding amino acids. Now, geometrical isomer. This question is quite an understanding question. If you don't understand the isomerism, you cannot answer this just by memorizing the things. So geometrical isomerism mainly for, you can see all these four options are dealing with octahedral complexes because the coordination number is 6. In octahedral complex we can see two types of geometrical isomerism, either cis trans or the FAC-MAR, facial and meridional. So here you can answer it with respect to cis trans only, but be careful with facial meridional also. It may happen that they give the four options where one can show the facial meridional isomerism, rest of the three show neither cis trans nor facial meridional. In that case you will get confused. So for the geometrical isomerism like cis trans, the facial meridional isomerism in octahedral complex is equally important. In this case, the option C, this bidentate ligand, you know, a bidentate ligand cannot stretch to accommodate two vertices which are trans to each other. They are always cis. So here this complex will be cis or trans with respect to the two monodentate ammonia ligand. Now, reason questions. Read the options carefully. Last year specimen paper, if you see in option D, it was assertion is false but reason is true, but this time they are giving both assertion and reason are false. So you may have practiced a huge number of assertion reason questions because these are very common nowadays in NEET exam, G exam. But most of the time option number 4, option D, we see that assertion is false but reason is true. But see here, this time council has given both assertion and reason are false. So read the four options properly, then answer. I am emphasizing on the point, read the question twice, thrice properly, read the question and then answer it so that you can avoid any mistake. So in this case, for the first one, both assertion and reason are true. However, I don't know why council has given this one as the reason. In Wurtz reaction, when same alkyl halides react with sodium in dry ether to give hydrocarbon, the hydrocarbon formed contains double the number of carbon atoms. So this should not be the reason, because if you are using tertiary butyl bromide, then you are having in tertiary butyl bromide 4 carbon. So 8 carbon containing alkane, it can be normal octane also. That is also containing double the number of carbon. But normal octane, n-octane is not the product here. Here the product is 2233 tetramethyl butane. So here the actual reason should be that in Wurtz reaction, from the two molecules of the haloalkane, which two carbons are getting bonded? The two carbons which are containing the halogen. In tertiary butyl bromide, the tertiary carbon is containing the bromine. So from two molecules of tertiary butyl bromide, the tertiary carbon containing the chlorine is getting bonded in Wurtz reaction, and that is why your product is 2233 tetramethyl butane. Here I have written the answer which is given by the council, that is option A. They are saying both assertion and reason are true, but that is a little bit controversial. As I said, N-octane is also containing double the number of carbon of tertiary butyl bromide, but that is not the product here. So the reason is not getting valid. So the original reason should be the carbon containing the halogen get bonded from two molecules when subjected to Wurtz reaction. Now, in the next part, the question is there is a continuous increase in size among lanthanoids with an increase in atomic number. Lanthanoids do not show lanthanoid contraction. So this is a very simple question, because if lanthanoids will not show lanthanoid contraction, then who will show? So from the reason line it is already clear that the reason is false, and there is a continuous increase in size. The term is lanthanoid contraction, so with atomic number the size will decrease, not increase. So just the council has introduced this option D, both assertion and reason are false. So somehow they make an assertion and reason in such a way so that option D get the correct answer. So it is a very simple question, and very clear to understand. But question 6 is a little bit controversial. The reason is actually not true from the sense of organic chemistry. So this is all about your section A. We have the paragraph question next. So this time they have given a paragraph, a passage, and that is related to radioactivity. So here the main thing that you need to know is radioactive decay follows first order kinetics. You have chemical kinetics chapter, there you study in details first order reaction. So a radioactive decay also follows first order kinetics. If you know this much, it is sufficient to answer all these three questions. So see here, uh, you can write this lambda as k also, like you write k for first order rate constant. But actually in nuclear chemistry, when we say about radioactive decay, it is known as a decay constant instead of rate constant. It is termed as decay constant, and decay constant is generally denoted by the Greek alphabet lambda. However, in the answers given by the council, you will see they are writing k, but actually it is lambda. Now you can use any of these three equation. I have written all these three. You can write any one. Either you write lambda equals to ln 2 by t half. Instead of ln natural logarithm, if you want to write log with base 10, then it will be 2.303 log 2 by t half. Or you know that ln 2, it has the value of 0.693. Most of you are habituated with this value 0.693. So you can write lambda equals to 0.693 by t half. That is also correct. So you can write any one of them. Then they are asking the age of the old wood. So it will be initial activity by final activity, because final activity means the remaining concentration. Final activity is analogical to the unreacted amount of reactant in first order chemical reaction, and initial activity is analogical to the initial concentration. So it is given that only 1/3 of the initial activity is remaining. So 1 by 1 by 3, so it will ultimately come log 3. And we are using this equation lambda equals to 0.693 by t half here instead of lambda. So this becomes the equation, and this part you can check in your calculator. The answer is coming this one, which is exactly same to the one given by the council. And another question is the time required. So this is the familiar form, the way we write. If a reaction is A to product, we write in this way. So see, I am using the same equation. just the terms look a little different in case of radioactivity. So here one thing, be careful, a common mistake that we see in your papers, that in the denominator this is the unreacted amount, the remaining amount. So sometimes when they in the question sheet is written 87.5% complete. So many times we see in the denominator you put 87.5. No, that is the amount which has reacted. This percentage is complete means that part has reacted. So remaining is initial minus that part. That is why in another step I have written this step 100 minus 87.5. Many a time we see students directly write in the denominator 87.5. Be careful, read the question. The part which has reacted, initial minus that part will be the denominator. The denominator is the unreacted amount. Next amount is the next part is simple calculation that you can easily do with the calculator. Now come to section B. Section A 14 marks we have done. Now come to section B. In section B we have 10 questions, each 2 marks, and out of these 10 questions for only one question you will have internal choice. So question 2, it is an understanding based questions, that is you have two electrolytes A and B and their molar conductance on dilution. Here we will assume that the dilution is up to equal extent. That means you are doubling the volume for both of them or tripling the volume for both of them. So for one it is increasing by 1.5 times, for the other 25 times. So here the important thing that you have to remember how molar conductance and specific conductance changes with dilution for strong electrolyte as well as weak electrolyte. So the thing is, for strong electrolyte the molar conductance increases slowly, for weak electrolyte increases rapidly, and for specific conductance it is decreases. Now it is decreasing rapidly for strong electrolyte and decreasing slowly for weak electrolyte. Here we are in the question, it is given molar conductance, so it is increasing, and as I said, for weak electrolyte it will increase rapidly, that is why it is 25 times, and for strong electrolyte it increases slowly, so only 1.5 times. So B will be the strong electrolyte, A will be the weak electrolyte. And here I have explained why it is slow and fast, because if you take a strong electrolyte that undergo complete dissociation, be it dilute solution or be it concentrated solution, so the number of ions are not changing if you are adding water. If you have 1 mole of electrolyte, the number of ions will be same, be it dilute solution, be it concentrated solution. For strong electrolyte, only the mobility of the ions, in a larger volume the ion can move faster, so only the mobility is changing, so you will see a slow increase in the value of lambda m. But for weak electrolyte, as the degree of dissociation increases, so the 1 mole of same weak electrolyte will give more number of ions in a dilute solution than a concentrated one. So here mobility as well as number of ions are increasing, so it will be very rapid. So you can answer in this way. Now the next question, this type of question, route map question, I always suggest that whenever you find this type of route map of question, try to draw an arrow diagram where all the informations given in the passage are included. Then as soon as you see the picture, it becomes easy for you to recognize the reactions, to remember the reactions, so that you can get the structure of ABCD. And that is what I have done. See this pictorial presentation of this passage. It is given A is a compound treated with concentrated NaOH giving B and C. B has the formula C7H8O. B on oxidation can give back A. C is a sodium salt of acid. When heated with soda lime and heat, it gives D. D is an aromatic hydrocarbon. So this is the pictorial presentation. So concentrated NaOH can remind you of Cannizzaro reaction. So assuming that, and one more thing, one trick I can give you, in most of the cases, not all the cases, I cannot say 100%, but in most of the cases what happens, if the formula is given and you see number of carbon is 6 or more than 6, you may assume benzene ring or phenyl ring is there. So if I simply remove the phenyl C6H5 from C7H8O, then what is remaining? If I remove C6H5, then what is remaining here? It will be simply benzaldehyde. See, C7H6 and O. Here it is C7H8O because you have treated it with concentrated NaOH. So for B, if it is a B on oxidation is giving A, that means A is reduced to B. So if benzaldehyde is reduced, it can be benzyl alcohol. Now try to match the formula of benzyl alcohol with C7H8O. Benzyl alcohol is this one. You have a CH2OH in the benzene ring, and see, this formula is matching with C7H8O. So you get the hint. So it is the Cannizzaro reaction. A is benzaldehyde. So obviously the other product will be sodium benzoate, that is also matching with the given information, sodium salt of acid. And sodium salt of acid, when heated with soda lime, it undergoes decarboxylation. The CO2 part is removed, this part COO. So it will be benzene, the hydrocarbon C6H6, and that is also matching with aromatic hydrocarbon. So 2 points I said here. One, whenever you find this type of route map question, try to uh, accommodate all the information in an arrow type pictorial diagram. And if the number of carbon in the formula is 6 or more than 6, start assuming phenyl or benzene ring is there. Most of the time it will help you, not 100%, but most of the time. Next question, devise a scheme. So if you see the answer given by the council, they have just written in words, apply Wurge reaction 2 times. But if you write in your exam, apply Wurge reaction by 2 times, you will get 0. So you have to show it like this. And remember, here you have to show the byproducts. I have shown in balanced way. Balancing may not be there in arrow diagram in conversion, but the byproducts you have to mention. And the best way to mention the byproduct is you write it as minus below the arrow. In that case, you don't need to write the equation every time. You can continue the arrow. So in this case, first your methyl iodide will be treated with sodium participating in Wurge reaction giving you ethane. Next you have to treat this ethane with iodine, and you know iodination of alkane is a reversible process. So we use a little amount of oxidizing agent HNO3 or HiO3, which oxidizes the byproduct Hi, this byproduct Hi back to I2. So according to Le Chatelier's principle, the forward reaction get favored and it goes for completion. So you get, so all the ethane can be converted into CH3CH2I. Now this one is again treated with sodium ether, again Wurge reaction. So now you get n-butane. So this is the model answer, the correct answer to score the marks. The answer given by the council in the published paper in their website, that one is just a hint. Next question. This is related to your Arrhenius equation. This is a simple formula put reaction question, but I will mention few points. Though it is a simple formula put question, but we find some mistakes. The most common mistake is student get confused whether it is 1 by T1 minus 1 by T2 or 1 by T2 minus 1 by T1. So I will say you a trick. If you are writing K2 by K1, it is 1 by T1 minus 1 by T2. So remember, in the log term, the one you are keeping in the numerator, in the right side, it will be in the minus form. If you are keeping the rate constant of 2 in the numerator, then temperature 2 will be minus. So similarly, if you write it log K1 by K2, if you keep the rate constant 1 in the numerator, then here it will be 1 by T2 minus 1 by T1. That is a trick to remember so that you never get it wrong. Another important point where you do the mistake, that is the value of R. Be careful when to use 8.314 and when to use 0.0821. So here we are supposed to calculate the activation energy in joule unit. So R must be in joule. So here it is 8.314. But if you remember osmotic pressure, pi equals to CRT, most often we use the pi in atmospheric unit. So there we use the R value 0.0821. So see the units of other terms then it will be clear to you whether to use 8.314 or to use 0.0821. For example, in Nernst equation, we are dealing with volt and coulomb, and you know volt into coulomb is joule. So there also the R value is 8.314. And the last point is, when you get the final answer, the unit of activation energy is not joule only, it is joule per mole. This per mole is very, very important, because activation energy is an intensive property. It is a property defined for 1 mole. Okay, so in this way, you remember these points so that you can get full marks for this type of formula put questions. Next question is again one root map type question. Now here the answer the council has given is ethyl cyanide, ethyl isocyanide, and they are writing cyanide gives primary amine, isocyanide gives secondary amine. That cannot be a reason, that is an observation, that cyanide gives primary amine and isocyanide gives secondary amine. That cannot be the reason. So what is the actual reason? If you see the structure of cyanide, you see the cyanide carbon is a 1 degree carbon because it is bonded to one carbon only, and your cyanide is getting converted into NH2. So obviously the nitrogen here in the cyanide, the nitrogen is bonded to only one carbon. So reduction means hydrogen is getting added across the C triple bond N. So obviously the nitrogen will remain 1 degree in the amine also. So you are getting primary amine. But if you see the isocyanide, the nitrogen is bonded to two carbon, left side the CH2 carbon, right side the isocyanide carbon. So the nitrogen is 2 degree here in ethyl isocyanide. So obviously in the product it will remain 2 degree, and that is why you are getting secondary amine. That is the reason. Observation is cyanide on reduction with LiLH4 gives primary amine and isocyanide gives secondary amine. That is the observation. But the reason is, in cyanide compound the nitrogen itself is 1 degree and it remain 1 degree in the amine because you are simply adding hydrogen across the pi bonds. So similarly in case of isocyanide, the nitrogen is bonded to two carbon, so it remains 2 degree in the product, so you are getting secondary amine. I have mentioned it. You can always pause the video if you want to copy the answer and you can write it. Or nowadays you are more fascinated with the screenshot, so that also you can take. Now this question. Uh, this is a simple question. Somehow they have made it a paragraph. It is a simple question. They are simply asking for this complex ion nickel tetracyanide 2 minus, what will be the shape and what will be its magnetic character. So for four coordinated complex, four complexes are very, very important in your syllabus. This is nickel tetracyanide, then it is nickel tetrachloride, nickel tetracarbonyl, and tetraamine copper. For these four complexes, you must remember the number of unpaired electron, the geometry or shape, and the magnetic character and the hybridization. For nickel tetracyanide, the hybridization is dsp2. It is a square planar complex and it is a diamagnetic complex. So the one who has written diamagnetic and square planar, he or she will be correct. So in this question, Suhel's response was correct and Pari's response was wrong. Now come to the next question. Again, root map type questions. So in this case, one by one we can calculate it. If you see the answer given by the council, they have just written what is X and just given the reactions. Here actually you have to start with the formula and first you have to calculate the double bond equivalent. That I hope you have learned in class 11 how to calculate the double bond equivalent. So I have applied the formula and it is coming 0. Since it is 0, that means there is no pi bond, there cannot be any ring. So this is an acyclic compound, non-cyclic compound. This is a non-cyclic acyclic compound and there is no pi bond. Now in the formula you see only one oxygen is there. It is acyclic compound. There is no pi bond. So only two options left. It can be either alcohol or an ether. Now in the question it is written it does not react with sodium. But you know, be it 1 degree, 2 degree or 3 degree alcohol, alcohol always react with sodium because of their acidic character, and you see the evolution of hydrogen gas. Since it is not reacting, so the compound must be ether. Now you try to match the other informations if it is ether. So in the question it is written, it is soluble in mineral acids. That is true for ether because they form oxonium salt like this. It does not react with sodium, obviously, because ether has no acidic hydrogen, so it does not react with sodium. Sodium can be stored inside ether. And then they are saying that it with excess HI, it gives a single alkyl halide. Now ether, when treated with excess HI, initially it gives alcohol and alkyl iodide, then the alcohol again react with the HI because you have given excess HI, and that is also converted into alkyl iodide. Now since it is giving only one alkyl iodide, that means the ether must be a symmetrical one. The two sides of the oxygen must be same. That is why you are getting one single alkyl iodide, not a mixture of two alkyl iodide. Now with the formula C4H10O, so C4H10, you have to split this part into two alkyl group which are same, and you can put it on the two side of oxygen to get the symmetrical ether. So obviously with two carbon it can be only the ethyl group. So two ethyl group on the two side of oxygen, so it must be diethyl ether, common name, or you can say ethoxyethane for the IUPAC name. So ethoxyethane, when treated with excess HI, it will give you only ethyl iodide, only one single alkyl iodide. And ethers are obviously not oxidized by KMnO4, because to oxidize ether you have to break carbon oxygen bond, and that is not an easy task because the bond energy is very high. So in this way you have to interpret the informations given. This type of question is at the highest level of organic chemistry. If you know each and every reaction of each and every chapter, then only you can carry out this type of problem, otherwise not. Now come to the next question. Identify AB. So this is a very simple question. Benzaldehyde first will be oxidized to benzoic acid, then SOCl2. It will give you benzoyl chloride. Benzoyl chloride treated with benzene, so that is your Friedel-Crafts acylation, and you will get benzophenone. The next one is propane treated with HgSO4, H2SO4. You know, ethane only gives aldehyde, acetaldehyde, but as soon as you go for higher alkyne with HgSO4, H2SO4, you always get the ketone. The addition of water will be according to Markovnikov rule, so you will get the OH here, and this one will be CH2, and that will tautomerize to give you acetone here, not propanol. To get propanol, hydroboration oxidation is required to get the anti-Markovnikov part. Now this acetone is treated with HNO3, and it is written vigorous oxidation. So under vigorous oxidation, acetone will give you a mixture of formic acid and acetic acid, because one of the carbon-carbon bond will break, carbonyl carbon and methyl carbon. So one fragment will contain one carbon, that will become formic acid. The other fragment will contain two carbons, so that will become acetic acid. But they are giving only A. Why? It should be A plus B, acetic acid and formic acid, but they are giving only A. Because here vigorous oxidation is written. First acetic acid and formic acid will be formed. That formic acid on vigorous oxidation with HNO3 will be further oxidized to carbon dioxide, and that will escape from the medium. So the product which is left is only acetic acid. And acetic acid with ethanol undergo esterification reaction. Concentrated H2SO4 acts as the catalyst to give you the ester ethyl acetate. So see the answer. Benzoyl chloride, benzophenone, acetic acid. As I said, formic acid will escape as carbon dioxide under vigorous condition, and this is the esterification. You are getting ethyl acetate. I have mentioned that point, that the formic acid will be oxidized into CO2 and nitrous oxide in presence of concentrated HNO3 under vigorous condition. Now this one is a very interesting question. ABC non-cyclic functional isomer of carbonyl compound. So carbonyl compound can be of two types, ketones and aldehydes, functional isomer. So A, B, C, they are either aldehyde or ketone. Now isomer A and C gives positive tolerance. So A and C they have to be aldehyde, not ketone. Compound B does not give positive tolerance. That means it obviously ketone. It cannot be aldehyde. And then they are saying gives positive iodoform test. So the ketone B must contains the ketomethyl group CH3CO. Up to this the informations are clear. Then A and B on reduction with zinc amalgam, that is the Clemenson reaction, give the same product, same alkane. So that also we will use. Now use these informations. As I said, these three informations. Now all A, B, C are non-cyclic functional isomer of carbonyl compound with formula C4H8O. So B is also C4H8O, that is a ketone with a ketomethyl group. So CH3CO part is fixed. If you remove the CH3CO part from here, the only thing left is C2H5, the ethyl group. So it will be butan 2-on. C double bond O, one side must be CH3 so that it can give the iodoform reaction. And after you subtract the COCH3 part from C4H8O, the remaining part is ethyl. So the other side will be ethyl. So the product is coming butan 2-on. Now it is written that A and B give same product on Clemenson reduction. So B butan 2-on, when undergoes Clemenson reduction, it will give butane, n-butane. So which aldehyde can give n-butane? It will be butanal, simple butanal. So A is butanal. So A is butanal and B is butan 2-on. Now what about C? So C is also an aldehyde because it gives positive tolerance and must be an isomer of A. So the only option left is this propyl group CH3, CH2, CH2. We know two propyl groups, one is n-propyl, another is isopropyl. So A is butanal, this is n-propyl. So the other one must contain the isopropyl group. So it will be CH3 whole to CH with CHO. And see, if this one undergoes Clemenson reduction, then the product obtained will be CH3 whole 2 and here CH3. That means you are getting 2-methyl propane, not n-butane. So the product is not same like B. Now the last question, which will be least reactive to addition of HCN. So addition of HCN, nucleophilic addition reaction, and you know there are two factors control this. One is the delta plus the positive charge on carbonyl carbon. Another factor is the steric hindrance. So you know in this type of reaction the order is formaldehyde greater than other aliphatic aldehydes, greater than aromatic aldehyde, greater than aliphatic ketone, greater than aromatic ketone. So here we have aliphatic aldehyde and aliphatic ketone only. So obviously the ketone, that is B, will be the least reactive because here you have two methyl groups, so more steric hindrance, and because of the plus I effect of the two methyl group and 6 hyperconjugation, the carbon is least electron deficient here. So here the reaction will be the slowest. Now next question is a numericals, and it is related to Nernst equation. Already I said in Nernst equation most often you make the mistake in the value of R, whether to put it 8.314 or 0.0821. You can avoid it by taking this value 0.0591, because when you are writing 0.0591 the correct value of R has been taken in the expression 2.303 RT by NF. So 2.303 RT by F, if you put R equals to 8.314, then only you get this value. Generally we use this equation at 298 Kelvin. In the question it is written 298 Kelvin. Sometimes you may find that in the question temperature is not mentioned. In that case also you can use 0.0591. But if by chance some other temperature is mentioned, then you cannot use 0.0591. You have to go for the original expression 2.303 RT by NF and put the value of temperature there, then you perform the carry out the problem. Now this is again a simple formula based problem, but here many points are there where you make the mistake. When you put this Nernst equation in the expression of Q, first mistake, which one will be the numerator, which one will be the denominator. Second mistake, about this square and cube, the powers. Third mistake, this minus sign, sometimes by mistake you write it plus. Fourth point, whether to take log or to take ln. So it is simple formula put problem, but these are the points when you make the mistake, and most often the mistake is with the value of n. So I have one very easy remedy to all this mistake, that is whether they are asking or not, first you find the cell reaction. Write the cathode reaction. From the cell expression you come to know the left side is anode, right side is cathode. So from left side you clearly come to know that the anode reaction is aluminium releasing 3 electron becoming aluminium 3 plus. The cathode Sn2 plus taking 2 electron becoming Sn. So write the anode and cathode reaction first, then balance the number of electron and add and get the cell reaction. It may happen that in the question they are not asking for the cell reaction, but I still insist you write the cell reaction first. If you write the cell reaction, you can never get a wrong expression of the reaction quotient Q, because you know how to write the expression of equilibrium constant. So product by reactant Al3 plus whole square Sn2 plus whole cube, and solid we take it 1. So you cannot be wrong with the numerator denominator, you cannot be wrong with the powers, and find the value of Q. And if you write the cell reaction when you are balancing the number of electron, you will always get the correct value of N also. Now you put the value of Q and N in the Nernst equation, so you can never be wrong. Another very important point, while calculating E naught cell, you mistake with this 2 minus. See here, both the E naught values are given minus. So very often we see you mistake with this 2 minus sign. This minus is this one in the expression, E naught cathode minus E naught anode, this is this minus. So you keep this minus and then you put the value. So I always suggest as a remedy, always write the value of the reduction potential in first bracket and keep this minus as it is. After that you do the calculation. So it can never be wrong with the plus minus. So now come to the next question. Distinguished question. Here in this slide, due to lack of space, I am not writing in the tabular form. I am writing in this way, but I always suggest for distinguished type of question, write the answer in the tabular form. Make a table with 3 columns. First column will be experiment, second column will be propan 2 all, third column will be propan 1 all. Then in the experiment column, you write this statement, and for propan 2 all, propan 1 all, write the corresponding observations. Now remember here, the 1 marks given for this question, it is half plus half for the 2 observation. Suppose this question can be carried out with iodoform test also. Propan 2 all will give it, propan 1 all will not. So suppose you are writing it with respect to the iodoform test. In that case, what will happen? Uh, Propan 2 all gives the crystalline yellow PPT of iodoform. Propan 1 all does not give precipitate, and suppose you forget to write propan 1 all does not give precipitate, you write it only for propan 2 all. In spite of being correct, you will get half, because the other part for propan 1 all you may think it will be understood, but actually it will not be understood. So remember here, whether it is giving any observation or not, you have to write for both the compounds, the two observations containing half and half. The experiment column is not containing any marks, but if you don't write the experiment column, you cannot write the observation for the two compounds. So it is must, but you cannot write, you cannot get any marks for writing only the experiment. If you simply write the answer, the two compound can be distinguished by iodoform test, you will get 0. The marks is given for the observation, and half for observation for each of the compound. So you have to write both of them. Similarly, for the next question, you can use here, I have used the neutral efficiency solution, but you can use iodoform test, azodite test, bromine water test, any test which gives distinct observation with naked eye. It may be evolution of some gas with characteristic smell, it may be effervescence of CO2, it may be some color change, it may be some precipitation, all this. Okay, so some distinct observation must be there. Now, the next question, it is again identify ABC, and for this type of question you can write simply the structure of A, B and C, that's all. You don't need to write anything extra. And for identifying ABC, you can write either the name or the structural formula or the structure. So these reactions are quite well known reaction, there is nothing to explain more here. Now the next question, it is a numerical problem. It is again a formula based problem. Now for the problems related to the solution chapter, it becomes a confusion when to use the Van 't Hoff factor, when to not, and for that you lose marks. I always suggest you that always use Van 't Hoff factor in the equation. whether it is undergoing dissociation or association or not, you always use the expression with the Van't Hoff factor. Now, if there is no dissociation, no association, the Van't Hoff factor will be 1, put it 1. In that case, you can avoid the mistake. In many times it happens that Van't Hoff factor, everything is correct, calculation, equation, everything is correct, but you forget to put the value of Van't Hoff factor and it is not 1. So your answer is wrong, you lose the marks. That always use the Van't Hoff factor in the question. So here I have answered the 3 questions. See, delta TF equals to, I have not used I here because I cannot make the mistake, but I suggest you that put I here, I into Kf into 1000 W2 by M2 W1, and then in the equation put I equals to 1, saying that there is no dissociation or no association, or since this is the calculated value, so we are not considering the Van't Hoff factor, because Van't Hoff factor is a correction factor. If you put the Van't Hoff factor, you cannot get the abnormal molecular mass. So if you put I equals to 1, why you are getting abnormal molecular mass? Because you are treating the solution as ideal, but actually it is non-ideal. That is why you are getting the molecular mass abnormal. So you put I, then put I equals to 1, you will get the abnormal molecular mass, and if you put the correct value of I, you will get the correct molecular mass. So the two abnormal masses will be obtained if you put I equals to 1, that is ideal. So in this way you are getting the two abnormal masses, abnormal molecular mass. Now Van't Hoff factor, it is formula normal molecular mass by abnormal molecular mass. What is normal molecular mass? The molecular mass that you get from the formula. So formula is NaCl, so it will be 58.5, that is the normal molecular mass. Abnormal molecular mass, that is the molecular mass you get experimentally by assuming the solution to be ideal and you are applying colligative property, that is abnormal molecular mass. So that we got 32.5. So if you take this ratio, you get the Van't Hoff factor 1.8. And similarly for acetic acid, you put the same formula. So acetic acid, the original molecular mass is 60 from the formula, and the one observed by considering it ideal is 113.789. So it is coming 0.527. Now we know that if I is greater than 1, it is dissociation. If I is less than 1, it is association. So from here you can say NaCl is undergoing dissociation here, and in benzene medium, the acetic acid is undergoing association. You know the reason, because of intermolecular hydrogen bonding. Now the last question. This is actually a blending of organic chemistry and physical chemistry. What will be the order of strength? Acetic acid will be the least acidic because of the plus I effect of methyl. Trichloroacetic acid will be a little stronger because of the minus I effect of 3-chlorine. And trifluoroacetic acid will be the strongest because fluorine has a stronger minus I effect than chlorine. So this will be the order of strength. Now in physical chemistry, what is the strength? The more it can dissociate to give higher concentration of H plus, the stronger is the acid. So if this is the order of acidic strength, then order of degree of dissociation will be same. Now, as degree of dissociation increases, number of ions will increase, so total number of particles will increase. So number of solute particles for the same concentration of the 3 acid, that will follow the same order of acidic strength. And greater the number of particles, it is colligative property, depression in freezing point. So greater the number of particles, more will be the depression in freezing point. So depression in freezing point will also follow the order of acidic strength. Now, this is the easiest question from organic chemistry. Directly the name is given and you have to write the equation. Now, one thing remember here, when it is a name reaction, you can show the equation, but it must be a balanced one. And you can show the equation with any of your choice of compound. For example, Rosenman reaction is given. I have shown it with acetyl chloride. If you wish, you can show it with benzoyl chloride or CH3CH2COCl. That is according to your choice. But the equation must be correct. And for name reaction question, the condition is very important. So here you don't miss the condition, don't miss the byproduct, don't miss the balancing. Only the compound can be of your choice. So in Rosenmund, you can take any acid chloride. You don't need to show it in general form like RCOCl. If you show it with RCOCl, then you have to mention R equals to alkyl or aryl like that. And in case of benzoin condensation and Perkins reaction, you don't have any other choice because these are specific reaction for these two compounds. Now, for this question, so they have fixed the ligand cyanide. See the question they are asking. Two coordination complex ions with cyanide and iron having coordination number 6. So coordination number they have fixed 6, so it will be octahedral. The ligand they have fixed, it is cyanide. So the only thing that you can, iron also they have fixed, the metal. So the only thing that you can change here is the oxidation state of the metal. So one will be with Fe2 plus, another will be with Fe3 plus. So the only two options left here is ferricyanide and ferrocyanide, and then you write the corresponding IUPAC name. In IUPAC name, be very careful. This is the part where the council marking scheme is the most strict. You miss one letter and it will be straight 0, no half marks. So be careful with the double M of amine. If it is suppose tetraamine, then the last A of tetra and first A of amine both will be there. Don't remove anyone like organic chemistry. So be careful with the spelling of IUPAC name of coordination entity. That is very important. And next part, crystal field splitting. If it is greater than pairing energy, that means pairing will occur. Electron will come from Eg to T2G. So from T2G3 Eg1, this Eg1 electron will come to T2G and it will become T2G4 Eg0. And if delta O less than P, then it is weak field ligand. The crystal field splitting is smaller than the pairing energy, so the electron will not come down from the Eg level to the T2G level. So it will be just like the free ion. So for D4 system, in free ion, it will have 4 orbitals, 1 electron each. So in the configuration also, for the 3 orbitals in the T2G lower level, you will find 3 electron all unpaired, and 1 electron in the Eg level, that is also unpaired. Now, this question is very important. In electrochemistry, few things are there which you have to memorize. Number one, note it down. Number one is corrosion. What reaction is taking place at cathode, what reaction at anode. Number two, hydrogen oxygen fuel cell. Again, reaction at cathode, reaction at anode. Lead storage battery, that is a secondary cell. It is rechargeable. Those cells which are not rechargeable known as primary, and which can be recharged like we use in battery, lithium ion battery, they are secondary cell. So lead storage battery is one of the secondary cell. So what are the reactions at cathode and anode during discharging when you are using it, and what are the reactions while charging? These are very important. In addition to that, this time they have given a question from dry cell. So the things related to dry cell also you have to memorize. You have studied this in class 9 or 10 most probably. Those zinc, carbon graphite rod, ammonium chloride paste, what are the consequences? So for this question, whatever answer council has given, I have written exactly that, because in this case it is simply informative question. But for the alternate question, what happens to the voltage when the salt bridge is removed, and they have written directly it will be 0. Why it will be 0? So what is the function of the salt bridge? To complete the circuit. So if you remove the salt bridge, the circuit is open. Circuit open means current is 0, and if current is 0, from Ohm's equation you know V equals to IR, voltage equals to current into resistance. Since current becoming 0, so voltage is also 0. That is why voltage is 0. Next, copper sulfate solution cannot be stored in a zinc pot. And if you see the answer given by the council, they have written with respect to the electrochemical series. But at this level, we should not use the concept of electrochemical series. Rather, we should use the concept of electrode potential. So here I have written the value, but you don't need to memorize the standard reduction potential values. Here from the question you can derive the answer. For example, if you see, copper sulfate solution cannot be stored. So the statement is clear, it cannot be stored. They are not asking whether it can be stored or not. In that case, the question will become difficult. They have written cannot be stored. So cannot be stored means obviously some reaction will be there. So you are keeping copper sulfate that contains copper 2 plus ion, and the container is zinc, so it is metallic zinc. So copper 2 plus will be reduced to copper and will get deposited, and the zinc will be oxidized to zinc 2 plus and will come into the solution. That is why you cannot keep it. If it is happening, then the copper system must have reduction potential greater than the zinc system. Only then it can take place. It will become spontaneous. So here, if you don't know the value, one thing you can surely write, that the standard reduction potential of copper 2 plus copper is greater than the standard reduction potential of zinc 2 plus zinc. Okay, here I have a mistake because I copied and pasted it and I forgot to make it zinc 2 plus zinc. This one will be E naught zinc 2 plus zinc, and that is minus 0.76 volt. So this reaction, spontaneous reaction, will take place, and that is why you cannot keep it. So if you cannot remember the value, just write the standard reduction potential E naught Cu2 plus oblique Cu is greater than E naught Zn2 plus Zn, and that is why this reaction will take place. So you cannot keep the solution. And this one I just mentioned, lead storage battery, very very important. You have to remember the reactions. Now this one is a very very interesting question. Glycine and alanine, they have given the structure. So you know, peptide bond, you have to remove one molecule of water from the carboxyl and the amine group from the two molecules. Now in a peptide, the sequence of amino acid is very very important. It is written glycyl alanine, so in the left side it will be glycine, right side it will be alanine, and the convention is the molecule at the extreme left, its NH2 group must be free. That means not involved in peptide bond formation. Similarly, the amino acid at the extreme right, its carboxyl group COOH will be free, not involved in peptide bond formation. So in this case, when you are writing the answer, keep the glycine NH2 at the extreme left, keep the COOH of the alanine at the extreme right. So actually these two will react, remove water, and you get an amide bond, which is known as peptide bond for glycyl alanine. Now suppose instead of glycyl alanine, they give the molecule alanyl glycine. In that case, you have to write this molecule at the left side, glycine at the right side, and in the dipeptide you will find the NH2 of alanine is free. That means here you will have a methyl, and the COOH of glycine is free. That means here you will not have the CH3, it will be CH2. The two molecules, the two dipeptides are different. If it is glycyl alanine and alanyl glycine, both the molecule contain one glycine molecule, one alanine molecule, one peptide bond, but the two molecules are not the same. In glycyl alanine, glycine has the free NH2, alanine has the free COH, but in alanyl glycine, the alanine will have the free NH2, glycine will have the free COH. Next, complete hydrolysis of DNA. So when you hydrolyze a nucleotide, the components of nucleotide becomes free. What are the components of nucleotide? The pentose sugar, ribose sugar, which is deoxyribose in case of DNA, and one nitrogen base, purine, pyrimidine, adenine, thymine, thymine, guanine, and cytosine. Here it is clearly written containing thymine, so the nitrogen base obtained will be thymine. And the nucleotides are connected by phosphate linkage, so that phosphate will also undergo hydrolysis and give you phosphoric acid. So the deoxyribose sugar involved in nucleotide of DNA is the beta anomer of D-deoxyribose, the D isomer, capital D, and it is deoxy at carbon number 2. That means at carbon number 2 you don't have any OH group, both are hydrogen. You don't need to draw the structure, only you have to write this much: beta anomer of capital D deoxyribose, and it is deoxy at position 2. The base will be thymine here, and you will get a phosphoric acid molecule because of the phosphate group. Next question is a direct question, reducing sugar. So carbohydrates which can reduce both Tollens and Fellings reagent are known as reducing sugar. There are many examples. Be careful with one example, and that is sucrose. Sucrose is the disaccharide which is a non-reducing sugar. It cannot reduce. Why it cannot reduce? I don't want to go that details. Otherwise the video will become very long. But you must remember sucrose is one of the disaccharide which is a non-reducing sugar. but the other two disaccharide in your syllabus, that is your lactose and maltose, they are reducing sugar. Now, this is a table-based problem from chemical kinetics, and here the trick is always try to find two observation where one of the component has constant concentration, the other one is changing. Then it becomes very easy to calculate the order. That is why here I have taken observation number 1 and 3. See, B is constant 0.1, but 1 is 5 times, and here it is also 25 times. So 5 square is 25, so order with respect to A will come 2. And if I take the observation 3 and 4, then A is constant, B is 5 times, but rate remains same. So it will be 5 to the power 0. So the order with respect to will be 0. So mentally you can calculate, and then you write in this way. You have chosen the experiment, so you have assumed the orders are alpha and beta. So you apply that in the rate equation, find 3 equation, and then one will be 2 divided by 1 and another will be 3 divided by 2. So you can calculate alpha and beta. Once you get the alpha and beta, you get the order. As soon as you get the order, you get the rate equation. From the rate equation, put the value of R, put the value of concentration A from any of the experiment, you get the value of K. I have used equation number 1 most probably to calculate K. Then once you get the value of K, then you can easily calculate R for any concentration of A. So here in the third question they have given the concentration of A. B is not required because with respect to B the order is 0. Whatever may be the concentration, it will not affect the rate of the reaction. So here the trick is find a pair of observation where one of the component has constant concentration, the other one is changing. Now come to the last section, section D. Here again they have given a paragraph. Write the chemical equation for the preparation of phenol from benzene using H2SO4 and NaOH. And if you see the answer given by council, they have clearly mentioned that give the equation, mention the byproducts. So this is the perfect answer for that. For the sulfonation of benzene, here we don't use concentrated H2SO4, we use oleum or fuming sulfuric acid, you can say. 353 Kelvin, first you get the benzene sulfonic acid. This is an acid treated with base, give you salt, which is a sulfonate salt, sodium sulfonate. Then this one is very important, solid NaOH. NaOH beads and we fuse it in anhydrous condition. Then only from the sodium benzene sulfonate you get sodium phenoxide. Na2SO3 comes as byproduct, and then acidification to get the phenol. Then they are asking what happens with bromine in carbon disulfide. This is a very famous question. Bromine water gives you the precipitate of 2,4,6 tribromophenol, but bromine in carbon disulfide only monobromination take place, and OH being orthopara directing group, you will get orthobromophenol and parabromophenol. And para will be major because it is sterically more viable. Then they have asked what will happen with neutral FeCl3. In some of the book it is written violet, in some of the book it is written purple, so you write both of them. And if it is substituted phenol, then the color can be red or green also, but with pure phenol the color will be either violet or purple. And this is the equation. If you cannot give this equation, okay, but just write the correct observation. It actually forms an octahedral complex. This complex ion actually shows this violet or purple color. Question number 4, be very careful with this 3H2O. So many times we have seen students write the correct product but forget this water. Same thing happens with bromine water, 2,4,6 tribromophenol. You give it 3 bromine, water must be there, but they forget to write the 3HBr as the byproduct. So be careful with the byproduct, otherwise you will lose the marks. And when your result comes out, you cannot understand where have you lost the marks because of this simple mistake. And last one is the Reimer-Tiemann reaction, and they have asked only for the equation, so you don't need to show the intermediates, how it becomes CCl2, then COH whole 2, then water is removed to get the CHO. They are asking only for the equation, so you write the balanced chemical equation. That's all. This one is from DF block. In DF block, these two types of questions are there. One, give reason type, another is balanced equation. So nothing to discuss much here, but for give reason type question 1 marks, remember you have to hit at the keyword. The keyword is very important. Sometimes it is vacant d orbital, sometimes it is presence of unpaired electron, sometimes it is due to variable oxidation state. Okay, sometimes it is very strong metal-metal bonding. So you have to hit at the correct keyword, and most of the time the answers are of one sentence. Okay, and here also suppose a question is given that copper 2 plus salts are colored but copper plus are not, and often students write copper 2 plus contain one unpaired electron, so it is colored, and you stop here. You are not writing for copper plus. Now in some of the years council says give full marks because it is understood copper plus will not have unpaired electron, but in another year in the marking scheme they say no, they have to write uh, separately for copper 2 plus and copper plus, so you give half marks. So whenever this type of question, comparison type question, like see here Mn2 plus and Fe2 plus, I could have written for Mn2 plus only that it has a stable 35 half filled configuration, so it is reluctant to oxidation. And I may assume that the examiner will understand Fe2 plus does not have stable configuration. But in the marking scheme, it may be clearly mentioned half marks for Mn2 plus, half marks for writing Fe2 plus. So see in the answer I have mentioned for Mn2 plus as well as for Fe2 plus. So make it a habit that when it is a comparison type question between two species, you are writing the statement for both the species. Then there will be no option to lose marks. And now the last question. It is from a solution chapter. So here I am using pi equals to CRT, but I suggest you write I into CRT and then you put I equals to 1 if it is ideal. If there is dissociation or association, put I accordingly. So it is simple formula, put equation and see pi here is given is 8.21 atmosphere. So I am putting R equals to 0.0821. This is the only point where you have to be careful. Then the next question is very interesting. Question number C. What would be the osmotic pressure of blood if the temperature is 37 degrees centigrade? So pi equals to CRT. Using that, first you find the value of pi 1 is given, C and T1 are given. So you can assume that the concentration of blood remains the same. Then you put it for find the value of C. Then put it in the second equation, pi 2 equals to CRT2. Instead of that, what you can do, since you are assuming C is constant, so pi varies with capital T. So pi 1 by pi 2 equals to T1 by T2. Now pi 1 is known 8.21, T1 is known 27 degrees centigrade, so 300 Kelvin, and T2 is given 37 degrees centigrade, so 310 Kelvin. So pi 2 you can calculate. But we often find mistake here. Many student instead of 300 put here 37, 310 put here 37, and instead of 300 put here 27. So that is why I have shown here that here you have to add the 273. Be very clear when to add the 273, when not. If it is a difference of temperature, delta T, T2 minus T1, then it will be same in centigrade scale as well as Kelvin scale. But if it is into T, not delta T, then you have to convert from degree centigrade to Kelvin. And here one interesting thing is they are asking the definition of isotonic solution. Most of the time we study that two solution having same concentration, but actually it is not correct. Mostly in biology books they are writing same concentration because in bio they are dealing with ideal solution and they are dealing with the physiological temperature 37 degrees centigrade. But we know pi equals to CRT, so pi depends on C as well as T. And not only pi equals to CRT, pi equals to actually I into CRT, so it depends on Van't Hoff factor also. So it may happen two solutions have the same concentration, but their Van't Hoff factors are different, so the osmotic pressure is different. So why the osmosis actually happens? Is it because of difference of concentration? No, it is because of difference in osmotic pressure. Now if other factors are same like Van't Hoff factor and temperature, then pi is directly proportional to C. So difference of pi means difference of C. That is what taken in biology. But in chemistry we will use that pi equals to ICRT. So we will go for the authentic, for the primitive definition of isotonic solution, that it is the same osmotic pressure, not same concentration. Now 0.91% is isotonic, so concentration less than 0.91% will be hypotonic and above 0.91% will be hypertonic. But it is below 0.91% and they are saying it hypertonic, so clearly it is a false statement. It will be hypotonic. And this is an informative question. Edema. Some more questions like this, that bent, deep sea divers, application of Henry's law, that disease is known as bent, BENT. Okay, so this type of informative question may be there. Now now in the alternate question also they have given numericals, two numericals, 2 plus 2, and one marks question. So here simply formula put and you can get the answer. See, here I am using I and I am putting I equals to 1. This should be your practice. If it is ideal, put I equals to 1. If it is non-ideal, put the correct value of I. So you can never miss the point. You can never make a mistake regarding the value of I for the problems. So simple formula put problems. The second one is also simple formula put problems. Find delta TF properly. Here don't make a mistake with this 2 minus sign. And see, here it is delta TF. So be it 6 degrees centigrade, be it 6 Kelvin, it is the same. So you can put the value 6 because it is delta TF. But if it is only T, then it will be 273 plus 6. So you find the value of W2. And this one is a very common question. You know which concentration scales are temperature dependent, which are not. Molality is a temperature independent because there is no volume term. Mole fraction is temperature independent. A percentage scale weight by weight, that is also temperature independent. When there is no volume term in the expression, that will become temperature independent. And if volume term is there, it is dependent. Like molarity is per 1000 ml or per 1 liter. So it is volume related, so it will be temperature dependent. So volume increases, molarity decreases with temperature. So you can see, according to this specimen paper, council this time have given question bank also with hints of answer. So you can see a lot of application based question, competency based questions are there. I hope I have covered all the points, how to write the answer, where you lose the marks. Be careful with the byproducts in organic chemistry, mention them when balancing is required. Okay, in the numericals, while putting the formula, be careful about the numerator, denominator, powers, value of R, etc. In inorganic, for DF block, be careful about the keyword that is required for give reason type of question. And I wish you all the best for your ISC 2025. And if you have any query, any doubt more after this session, then you can put your doubt in the comment box and I will try my best to answer you. Thank you and all the best for your 2025 ISC exam.